Hello viewers, welcome to another video. In this video, we will study KVL or Kirchhoff's Voltage Law or Mesh Law. First, we will see what the KVL law states. The algebraic sum of the products of currents and resistances in each of the conductors in any closed path or mesh in a network plus the algebraic sum of the EMFs in that path is 0. So mathematically, you can see that summation IR is the algebraic sum of the product of current and the resistance, which becomes the voltage across the resistance, plus the algebraic sum of all the EMFs is equal to 0. So this is the KVL. In applying the KVL law, it's very important to determine the correct voltage sign when solving the equation in a loop. So here you can see that if we move from the negative terminal of the battery towards the positive terminal of the battery, the voltage should be given the positive sign, or we can say that there is a rise in the voltage when we move from the lower potential to the higher potential. Similarly, if we move from the positive terminal of the battery to the negative terminal of the battery, there is a fall in the voltage and the voltage should be given the negative sign. Now let's look at the sign of IR drop. If we move in the direction of the current through the resistor R, then the voltage drop is indicated by the sign negative. It means that the current is moving from the higher potential towards the lower potential. So minus V is equal to minus IR. Here you can see that if the current direction is from terminal B to terminal A, and if we are moving through the resistor opposite to the direction of the current, it means that the voltage sign will be positive because we are moving from the lower potential towards the higher potential, and the plus V is equal to plus IR. So these figures are very important to remember when determining the voltage sign during solving the equation. So let's solve an example. Here you can see we have 3 loops or 3 meshes, and we have to determine the value of V3, V1 and V2. So first of all, starting from point A and applying Kirchhoff's voltage law to loop number 3, we get, so here you can see the direction of the current is in the clockwise direction. Starting from V3, the current is entering from positive terminal of the V3 and exit from the negative terminal. So the V3 is indicated with sign minus. Now here you can see the current is entering from the negative side of this 5 volt battery and exit from the positive side. So here we have a rise in the voltage. So the 5 volt is indicated with the sign plus, and both these voltages in a loop is equal to 0 according to KVL. Now solving this equation, the V3 comes out to be 5 volt. So here V3 is 5 volt. Now let's solve the second loop, which is loop number 1. So here is the equation of the loop number 1. Again, first look at the direction of the current. Again, the direction of the current is clockwise. So starting from 10 volt battery, the current entering into the negative side and exit from the positive side. So here we have the rise in the voltage. So 10 volt is indicated with the sign positive. In 30 volt, we have drop in the potential or the fall in the voltage. So the 30 volt is indicated with sign minus. And here you can see the current is entering from the positive side of the V1 and exit from negative side. So this V1 is indicated with the sign minus. And here V3, which is already equal to 5 volt. And here we have a rise in the potential across V3. So we write plus 5 and all 4 voltages are equal to 0. So solving this equation, the V1 comes out to be minus 15 volt. The negative sign of V1 denotes that its polarity is opposite to that shown in the figure. Here you can see in the figure, the positive is towards the terminal B and the negative is towards the C. But according to this equation, the negative sign shows that the positive terminal of the V1 should be towards the C and the negative towards the B. So finally, let's solve loop number 2. Again, the direction of the current is in the clockwise direction. So first of all, the current enters from the positive side of this minus 15 volt battery. So here we have fall in potential. So the minus 15 volt will be written with negative sign. In V2 we have again fall in potential. So the V2 is again written with negative sign. And here the current enters from the negative terminal of V1 and exit from the positive. So we have a rise in the voltage across V1. So the V1, which is already equal to minus 15, is written with positive sign, and all three voltages in a loop is equal to 0. So here V2 is equal to 0. It means that there is no voltage across this terminal, or you can consider this terminal as short. So this is how, by applying the KVL, you can easily solve any loop and determine any value of the voltage source. So I hope you clearly understand what is KVL and how we apply the KVL in order to solve any DC circuit. For more interesting videos, stay tuned and don't forget to subscribe our channel. Thank you for watching.